How to build your own personal AI assistant, but in a way that's a bit more real-world and less like a cartoon robot. So you're probably looking for something practical and maybe even a bit cool. Think of it like building your own Jarvis, but for your personal knowledge. You've got tons of notes, research, maybe even code snippets scattered around. This AI will be your command center for all that info. 1. Data ingestion, getting your brain dump into the system. Your data source, where's your stuff? You've got files scattered across your laptop, right? Maybe notes from lectures, coding projects, or research papers. We need to get that into a format the AI can use. Start with a single folder of .txt or .md files. If you're feeling adventurous, you can explore APIs for tools like Notion. Data processing, cleaning and organizing. Python is your friend here. Libraries like OS, Glob, and Markdown will help you read and manipulate your files. Chunking, break down large documents into smaller, logical chunks. This is crucial for the AI to find relevant info quickly. Imagine it like tagging sections of your notes for easy retrieval. Storage, where to keep it all. For a basic setup, you can use JSON files. For something more robust, consider MongoDB. It's a NoSQL database that's perfect for handling unstructured data. 2. Vector indexing, making your data searchable. Embeddings, turning text into numbers. Think of embeddings as a way to represent the meaning of words and phrases as numbers. This allows the AI to understand the context of your notes. Sentence transformers, a popular and easy-to-use library for generating embeddings. OpenAI embeddings, if you have an OpenAI API key, their embeddings are top-notch. Vector database, storing the embeddings. You need a place to store these numerical representations. ChromaDB, a good open-source option for local storage. Pinecone or Weaviate, cloud-based vector databases for larger projects and faster performance. Indexing, connecting embeddings to your data. Make sure the AI knows which embedding corresponds to which chunk of text. 3. LLM, the AI's brain. Choosing your LLM. OpenAI API, GPT 3.5 Turbo, GPT 4 powerful, but requires an API key. Open-source LLMs, Llama 2, Mistral 7b can be run locally, but require more setup. Fine-tuning, optional. If you want the AI to have a specific voice or understand your niche jargon, fine-tune it on your data. Unsloth can make this process easier. Prompt engineering, telling the AI what to do. Craft clear and specific prompts to guide the AI's responses. 4. Agentic RAG layer, orchestrating the process. Retrieval, finding the relevant info. When you ask a question, the vector database retrieves the most relevant chunks of text. Summarization, condensing information. If the retrieved text is too long, the LLM summarizes it. Reasoning and planning, advanced. Frameworks like LangChain or Smallagents allow you to create agents that can perform multi-step tasks. User interface, how you interact with the AI. Start with a command line interface or a simple web app using Flask or Streamlit. Gradio is a great tool for building interactive UIs. 5. Observability, keeping an eye on things. Logging, tracking everything. Log user queries, retrieve data, LLM responses, and system metrics. Evaluation, checking the AI's performance. Manually review responses and use LLM evaluation tools. Iteration, making improvements. Use the logs and evaluation results to refine your system. Practical tips. Start small, don't try to build everything at once. Focus on getting the core functionality working first. Iterate and improve, this is a learning process. Don't be afraid to experiment and make changes. Leverage open source, there are tons of great open source tools and libraries available. Community resources, check out online forums and tutorials for help. This is your chance to build something that's genuinely useful for you. It's a project that will teach you a ton about AI and software development. Go for it.